This video is going to be talking about comparing and ordering numbers in scientific notation. If you haven't watched the scientific notation video yet, you'll want to check that out first. Alright, the trick here is just look at the exponents. Now I'm going to take you through a longer process, but I'm going to show you how you can just look at the exponents and it'll help you figure things out. Okay, here we're going to just do comparing between two expressions. We have an expression on the left, we have an expression on the right. These are both expressions that are written in scientific notation. If you were to work these out the long way and just write this out in standard form, over here on the left we would need a total of 3 zeros. If you don't understand how I got that, make sure you check out the scientific notation video. Over here, this is a large number. It's only going to need 5 zeros. So here you go. Now obviously when you have 78,000 compared to 3,200,000, it's going to be a less than symbol. Now the quick trick for this though is to just look at the exponents. As soon as you see this 10 to the 4 compared to the 10 to the 6, the 10 to the 6 is going to have more zeros involved. So therefore, you can just make the decision without even having to work out the numbers. Just look at the exponents. Let's try another one. So for this one, pause it if you want, take a look at it, take a stab at it. With this one, we both have negative exponents. If you were to work these out, this would have a total of 4 zeros, 3 holding place values. This one would have a total of 6 zeros in front, 5 of them holding place values. Now, if you look here, the tenths, hundredths, thousandths, 10,000ths place is a 7 here. Over here in the 10,000ths place is a 0. So we're going to put a greater than symbol up because the 7 beats out the 0 in the 10,000ths place. Now once again, you can just look at the exponents. You can see that negative 4 is larger than negative 6. The exponents will tell you how to figure it out, so you don't have to go through this whole process. Up here we have another one. Hopefully by now you're catching on. This should be a greater than symbol because this exponent of 8 is a larger than exponent of 3. Let's just work it out long ways. This is going to have a total of 6 zeros. Since it's a positive exponent, the zeros are going to go to the right. Over here we're going to have a total of 2 zeros. So 125 million is definitely larger than 4,800. Once again, you could have just figured this out by looking at the exponents. 8 is greater than 3. This is definitely going to have more zeros involved. Another one with negative exponents. Pause it if you want. If you know how it goes now, if you know the trick, negative 7 compared to negative 5 would be less than, so therefore I'd be putting a whole less than symbol. If we worked it out, this one would have a total of 7 zeros in front, 6 of them holding place values. Over here we'd have a total of 5 with 4 of them holding place values. If we look at tenths, hundredths, thousandths, 10,000ths, 100,000ths, if we focus on the 100,000ths place for both of them, we see that the 9 is going to be the winner. So we're going to have a less than symbol. Once again, you could have just looked at the exponents. Negative 7 is less than negative 5. When this is scientific notation, this trick works. If this was just like a 5 to the something and another number to the exponent, you couldn't do this trick. But when we're comparing two numbers in scientific notation, we can use this trick. We've been focusing on looking at the exponents, but here they match. Well, then you can tune into the first number and just compare those. 3.2 compared to 5. 3 2/10 compared to 5. We should put a less than in there. If we work it out, total of 7 zeros, 6 of them holding place values. Over here, a total of 7 zeros, 6 of them holding place values. When we compare corresponding place values, that's going to be the tenths, hundredths, thousandths, 10,000ths, 100,000ths, millionths, 10 millionths. When we compare the 10 millionths place, we see that we're going to put a less than symbol in here. Once again, if we use the trick, we'd look at the exponents. They were tied, but then we'd have to look at the first digit. 3 2/10 is less than 5. So really, the only time you need to tune into the first number is when the exponents are equal. So now what we're going to do is talk about ordering numbers in scientific notation. I'm not going to work them out anymore. I'm just going to go ahead and, I know the trick, we're just going to look at the exponents. We have a 4, a 5, and a 7. We're going to write them in that order. 6 times 10 to the 4th, 4 76/100ths times 10 to the 5th, and then 5 2/10 times 10 to the 7th. Now if we wanted to, these are least to greatest. We could put less than symbols in between each of these. 6 times 10 to the 4th is less than 4 76/100ths times 10 to the 5th, which is less than 5 2/10 times 10 to the 7. That's all you need to do. So we're going to look at the exponents, and we see with negative exponents, the ones furthest away from 0 is going to be the smallest, and then the next furthest away from 0, and then we have this one. Once again, we can put these less than symbols in between. So this is less than this, which is less than that. In this problem, we have matching exponents. So we're going to look at those exponents, see that they all match, and then we're going to tune into the first number. So we're going to look at the first number 4, that's the smallest. We're going to look at the 4 7/10 times 10 to the 7th, 6 76/100ths, and then we can put is less than, is less than. So this one is less than this one, which is less than this one. That's about it. I hope this helps. Best of luck to you.